Okay, you should have your books out and you should be opened up to page 632. On page 632, we're going to take a look at problem 10.9. 10.9 says, here are the IQ test scores of 31 7th grade girls in a Midwestern school district. So there's the 31 scores. You can see them 114, 110, 104, 89, so on and so forth. Treat these girls as in a simple random sample of all 7th grade girls in the school district. Suppose that the standard deviation of the IQ scores of this population is known to be sigma equals 15. A. Construct and interpret a 99% confidence interval for the mean IQ scores of the population. Follow the inference toolbox. Okay, it tells you to follow the inference toolbox, but most questions will not even say that, and I still expect you to follow the inference toolbox. So step one is the parameter. So watch how I do this. I will write it out. Step one. The parameter. Okay. What is the population? And what is the parameter I'm looking for, or that I'm making an assumption about? Okay. The population is all 7th grade girls' IQs in the school district. Actually, we're talking about the mean of 7th grade girls' IQs in the school district. That's the parameter that we're looking for. Mu is that true mean of IQs. Okay? That's what mu is. That's what we're looking for. Notice how I write it out and I identify it. Step two. Okay? Step two was conditions. Are conditions met? You have to go through and identify and verify that every condition is met. So I would say number one tells me yes, it is a simple random sample. It tells me in the problem that yes, you can assume it's a simple random sample. But notice, I have to identify that. Okay? In the problem, simple random sample. Yes, it's there. Number two, is it normal? Can I assume that it's normal? Well, if we look, okay, how many samples do we have? What's the number of samples we have in our sample? Okay, what's the number of IQs we have in our sample? N equals 31. So yes, N is large enough to assume that the sample distribution is approximately normal. Okay? Notice how we use the word approximately normal. We don't say it is normal. We say it's approximately normal. Everything we talk about is going to be approximately normal. And we're going with that little guideline in our book that says, 30s are usually a good gauge to go by. And then the third one, independence. Do we have independence? Well, the thing to check there is 10 times n less than the population? And so 10 times 31 equals 310. I would say that there are at least 310 7th grade girls in the school district. Okay. Let me stop right there though for a quick second. And Roy, this is just for you. So Roy, if you're done taking your test and you're listening to this, that if one of these three conditions is not met, and I'm taking the AP test, does that mean I stop and say, condition doesn't work, can't finish the problem? No, you finish the problem in the context, but then when you go back in your conclusion, in your interpretation, you say, these are the conclusions I got, but I don't think it came from a simple random sample. Or I got these conditions under the fact that I assumed it was a simple random sample. Okay? You don't just stop if these conditions aren't met on the AP test. You continue on just with the little sidebar note saying this condition was not met. But you still have to check every single one of them. Okay? So I'm on step 3 of 4 steps. Now is when the actual math starts. We start by saying step 3 are the calculations. Okay, my calculations. Step 3. So find x bar by using your lists. Okay? I actually already did it. I did this example a little while ago, and I put them all into my list, and I calculated x bar equals 105.84. Okay? That's the mean of all of those IQs, the 31 IQs that are in your book. That's the mean. Okay? So then my margin of error. My margin of error is going to be 2.576 times 15 over the square root of 31. Where did this 2.576 come from? That's from my 99% confidence level. Okay, remember, that's how many standard deviations we are away, so that we get this idea of basically 99% of my data is in the middle here. And I have 0.5% over here, 0.5% and 0.5% on each tail. Okay? That's where my 2.576 came in. So then that gives me a margin of error of 6.94. So then my confidence interval is going to be 105.84 plus or minus 6.94. That's my confidence interval. Or we can write it using interval notation, which is 98.90 to 112.78. Again, interval notation. So this is all step 3. Your calculation came from, the big part here is where did my 2.576 come from? Came from my confidence, or my 99.9 confidence level. And again, we used my estimate plus or minus my margin of error. Okay? So again, that's my x bar plus or minus my z star times sigma divided by the square root of n. And then the last step, step 4, step 4 is we have to interpret that. So I came up with, let's write step 4, interpret, okay? This means with 99% confidence, okay, with 99% confidence, we estimate that the true mean of IQ scores is between, actually, IQ scores for 7th grade girls in the school district is between, and we said 98.90 and 112.78 points. Okay? So that's part A. Notice how much work I put into just part A. You have to hit all 4 steps. Okay? And then part B, I think it asks something about, part B says, if these girls actually came from one teacher's class within the school district, how would your work in part A have been changed? Basically, this is what I was talking about earlier. I would have just said, no, it wouldn't hold true. It would not hold true because step 2, number 1, simple random sample, was not true. But you could just make that little caveat and say, if it were true, then this is the way the results would come out. Okay? Alright, so what I would like you guys to do for homework right now, I'd like you to work on, let me make sure I've got this, and Mr. Dodros probably already told you, but I'd like you to do problems 10.1 through 10.5, and then 10.10 through 10.12. Come ready to show these on the document camera. I'll call on you individually. Come ready to show these on the document camera on Thursday. Okay? Hope you guys are having a good day.